folks, let's start to look at example 8. So example 8, I've got some fractions here. I've got another fraction here. I want to solve this rational inequality, but what I need to do is get this 1 over x onto the left side. And then I need to get least common denominators and simplify whatever is on the left side. So my first step is going to be to subtract 1 over x, right? This will cancel out by design, and I will be looking at 1/2 minus 3 over 2x squared minus 1 over x is going to be, and oops, I put less than. JK, let me move this back. I got to look at my original symbol. It's actually going to be greater than or equal to 0. Okay, so I have fractions here. Let's go ahead and find the least common denominator, multiply each of these fractions by their own unique version of 1, and simplify. So if I look at my LCD, I can see a 2 here, a 2 here, a 1 here. So that least common multiple is 2. Here there are no x's. Here's x squared. Here's x. I need to take x with the highest power. So my LCD is 2x squared. So I'm going to take each of these fractions, right, and I'm going to multiply them by their own version of the number 1. So I'm going to take 1/2, right? That's my first fraction. If I look at this denominator, in reference to my least common denominator, I'm missing an x squared. So I'm going to multiply it by x squared over x squared. Right? Now I've essentially, all I've done is taken 1/2 and multiplied it by 1. So I haven't changed anything because, oops, let me remove that mark. I haven't changed anything because 1/2 times 1 is still 1/2. All right, now let's put in our second fraction. So minus 3 over 2x squared. All right, well, if I look at 2x squared, this denominator to my common denominator, it's there. So really, I don't need to multiply it by anything. I mean, if it helps, you can multiply it by, if you're thinking about it, 1 over 1. But I don't need to multiply it by anything because that denominator is the LCD. It was all ready to go, which is great. All right, let's take this third fraction, minus 1 over x. Okay, from this denominator to my LCD, I can see I'm missing the 2, right? This is x, this is 2x squared. So I'm missing the number 2. I'm also missing a power of x because this was x and this is x squared. So I'm going to multiply this fraction by 2x over 2x, and I'll keep that greater than or equal to 0. So I'm starting to get all of my fractions written with that least common denominator. And I'm going to PEMDAS. I'm going to find this product first and this product. And then I'll do the addition subtraction. So whenever you got fractions that you're multiplying, multiply numerators, multiply denominators. So 1 times x squared, I'm going to put a little arrow here. So 1 times x squared is x squared, right? 2 times x squared is 2x squared, which is great. We want that LCD to be 2x squared. I didn't have to do anything to this fraction. So we've got 3 over 2x squared. And then this product, all right, I've got numerator, let me put the subtraction sign. So 1 times 2x is 2x, and then x times 2x squared is 2x squared, which is what we wanted. We wanted all of these denominators to ultimately be the same, and I'll keep that symbol, greater than or equal to 0. So now that I've got these common denominators, I'm going to go ahead and combo up the numerators over ultimately 2x squared, and that's going to be greater than or equal to 0. And for me personally, I like to write my powers of x in descending order. So I'm going to write x squared minus 2x minus 3, and that'll also help me for when I eventually want to factor. All right, so let's look. I've got x squared minus 2x minus 3 over 2x squared greater than or equal to 0. So I'm in better shape than I was originally because here I had the 1 over x to start. Now at least I have the 0. I could take it a step further because ultimately once you have the 0 on one side of the inequality, your game plan is to set numerator and denominator to 0 and solve for x. So I'm just going to go ahead and factor that numerator while we're here. Okay, and when I factor the numerator, you use any method you want. AC method, guess and check, Punnett square, whatever you feel most comfortable with. But two numbers that multiply to -3 but add to -2, I like to guess and check. That's going to be x minus 3, x plus 1 as I start to work that. And then I've got 2x squared on the denominator, all right, greater than or equal to 0. So this is going to be the new rational inequality I'm going to try and solve for. So let me scooch this up just a bit so I have some more space. All right, and then we're going to try and solve this rational inequality. So let me set, and I'll put a little separation here. All right, so I'm going to set numerator to 0, x minus 3, x plus 1. And then I'm also going to set the denominator to 0. These are going to help me find the interesting points or the interesting values of x that I want to put on my sign pattern. So here I would get x minus 3 is 0, or x plus 1 is 0. If I divide both sides by 2 here, I'm going to get x squared equals 0. So if I solve these a little bit more, I'm collecting x is 3 or negative 1. Here, I could square root both sides and I would get x was plus or minus the square root of 0, because that plus or minus shows up when you're square rooting a variable, right? But square root of 0 is 0, and the positive version of 0 and the negative version of 0 are both 0. So I ultimately have 3 values of x that I want to put on my sign pattern. I want to put a negative 1, I want to put a 0, and I want to put a 3. So I'm going to scooch this up a little bit. I'm going to try and keep my inequality in view just so we have it there as a reference. So let me go ahead and try and make a sign pattern now. And then let's see quite literally what signs we want when we're done with this. Okay, so I'll put my little x-axis. Okay, let me remove my ruler. So we've got x down here, and I'm going to put the factor, oops, I put a dash through. I'm going to put the factored form. So what do we have? X minus 3, x plus 1, and then 2x squared. Okay, so I'm going to go from left to right, low to high. So we're going to go negative 1, 0, 3. All right, so let's start to think about if I'm going to put zeros or DNEs here. So if I plug negative 1 in, negative 1 will zero out my numerator. And when you have a fraction whose numerator is 0, then the fraction's ultimately 0. When I plug 0 in, all right, 0 literally zeroes out my denominator. And when I have a fraction whose denominator is 0, the fraction doesn't exist. When I plug 3 in, that zeroes out my numerator. So ultimately my fraction is 0. So now it's a game of, I'm going to put a plus or a minus here, plus or a minus here, plus or minus here, plus or minus here. And you can pick test points. You could pick something like 4, I don't know, 1, negative 1/2, let's go with like negative 3. You could plug them into this fraction and quite literally just keep track of the positives and negatives. And let me do one of these with you, and then I'm going to show you like my more shortcut method that I do. So let me erase all these plus minuses. You'll have to forgive it's not even my dog, my neighbor's dog is barking if you hear that. Okay. So just to remind you, because I've been doing it the shortcut method the last few examples, if I tried 4, right, if I plugged 4 in, 4 would make 4 minus 3 positive, 4 plus 1 positive, and 2 times 4 squared positive. And a positive times a positive in ratio to a positive is positive, right? And to just change this up, if I plugged 1 in, right, if x was 1, if I plugged 1 in, this first factor would be negative. This one would be positive, right? Because 1 plus 1 is 2, which is positive. 2 times 1 squared would be positive, and a negative times a positive in ratio to a positive is ultimately negative. So you can pick those test points, okay? But I'm going to erase this because I want to show you this is how I do it. And I don't mean that to sound braggy. This is just experience, right? So I start with what's going to be the lead positive or negative. And when I say lead, it's the one all the way on the right. And then I work myself right to left, which is opposite of how we usually do the x-axis. We usually go left to right, but this is that like shortcut method that works this way. So what I mean by that is if I look at the lead terms, and I don't know if we can see them, yeah, we can. My lead terms before I factored were x squared over 2x squared. So I had my lead terms as x squared over 2x squared. There's secretly a 1 here. So this is behaving like positive 1/2. And I know there's other stuff. I'm not denying there's other stuff, but this is the shortcut method for sign patterns, that you only have to look at the lead terms to determine this sign. Since positive 1 over positive 2 is positive, that gets the plus sign. And that was consistent from when we plugged in the 4. All right, and then once you figure out the lead term, you look at the powers from your factor. And I'm just going to say if you have an odd power, right? Your signs will alternate. Can we see me writing the word? Oops, you can't quite see that. Let me scooch this over. I just realized I'm kind of running up on the side of what you can view. So if you have an odd power, right, I think we can see it if I write it here. Yeah, odd power. I'm just gonna write the word alternate. Your signs will alternate, and I'll show you what I mean in a moment, right? Even power, all right, do not alternate. Okay, so let me go through this, right? I found I had that lead positive because +1 in ratio to +2 is a positive. All right, then, and I'm gonna go right to left, which is counter to how we do the X stuff almost every other time. All right, I hit 3. That's the first thing I come to. That comes from the factor of X minus 3, which has an odd power here. All right, and since it has an odd power, my signs will alternate. So since this was plus, it'll change, it will alternate to a minus, okay? Then I hit this X value of 0. That came from X squared. Since that is an even power, I'm not going to alternate. So if this was a minus, I'm not going to change it, I'm just going to keep it as a minus. All right, then we run across -1. -1 came from X plus 1, which had an odd degree there. Right? And since it was odd, I'm going to alternate, so I'm going to change from minus to plus. So that's, to me, the faster way. I know I spent a good chunk of time explaining it, but ultimately, I can go pretty quickly through these. Like if I'm just looking, I say, okay, I've got positive here, and then the only thing, I call it bouncing, right? I just knew I was going to bounce around X equals 0, meaning I'm going to go minus, minus. And the reason I say bounce is because if you graphed it, you would see it hit the x-axis and not pass through it. But that's a conversation for a later time. Okay, I want greater than or equal to 0. So I want to collect plus signs, and I want to collect zeros. So let's see what we got. I see a plus sign here. I see a 0. Right, so I want to include that. I see another plus sign here and another 0. So I want to write those intervals up so it looks like I'm going from -∞ to -1. And then I'm going to head over to 3 and infinity. All right, and can we see what I wrote up? Yeah, okay, all within view. So there is my answer to example 8, okay? Thanks so much. Bye.